In this video, we're going to take what we just talked about in 8.2 with systems of first order linear differential equations and apply it to that were homogeneous and apply it to those same kinds of systems that are non-homogeneous. And I'm just going to use the method of undetermined coefficients for these problems. There's also some problems in the section where you can use variation of parameters. You would not want to use variation of parameters when it's possible to use undetermined coefficients, since it's a much easier method. But those problems are there. I'm just not going to do any of those. If that interests you to go and see what your solutions would look like if you used variation of parameters instead, go ahead and read that part of the book and see how that changes how your solutions look. But let's go ahead and get started here with number 1, which says dx dt is equal to 2x plus 3y minus 7, and dy dt is equal to negative x minus 2y plus 5. So that turns into a system for me of x prime is equal to 2, 3, negative 1, negative 2, capital X plus negative 7, 5. So my characteristic equation here is going to be 2 minus lambda, 3, negative 1, negative 2 minus lambda, which is going to be equal to negative 4, minus 2 lambda plus 2 lambda is 0, plus lambda squared, and then minus a negative 3 is plus 3, is equal to lambda squared minus 1 equals to 0. So I'm going to say that lambda squared equals 1, meaning that lambda is equal to plus or minus 1. So lambda 1 is going to be 1. Lambda 2 is going to be negative 1 for me. That gives me, when lambda 1 is 1, I have 1, 3, negative 1, negative 3, 0, 0. That turns into 1, 3, 0, 0, 0, 0. K1 is equal to negative 3, K2 is equal to negative 3t, with K2 equal to t. So that's going to be K1 is negative 3, 1. Lambda 2 is equal to negative 1. I have 3, 3, negative 1, negative 1, 0, 0. So this turns into 1, 1, 0, 0, 0, 0. K1 is equal to a negative K2. And K is equal to t. And I might as well let t be a negative 1 here. It really doesn't matter. I can have negative 1, 1 or 1, negative 1. I prefer to have 1, negative 1 as my matrix here. Like that. They're just opposites of one another is what that says. So that gives me an xc of c1, negative 3, 1, e to the t plus c2, 1, negative 1, e to the negative t. Now let's focus on my xp, which looks like it's just going to be a couple of constants. And so the book is using A1 and B1 for their constants. I'm not. I'm going to follow the degree of the term of the polynomial, and I'm going to call this A0 and B0, and say that that means that xp prime is 0, 0, and set up my equation here, swapping sides where xp prime is on the right, and then I have my coefficient matrix times my xp matrix, and that gives me 2a naught plus 3b naught equals 0, and negative a naught minus 2b naught is equal to 0 as well. Let's see, I have plus negative 7 and 5 that I forgot to write in that space there. So when I bring them to the other side, this is 7 and this is negative 5. So multiply my second equation by 2. Actually, let me just set up a matrix for this. 2, 3, 7, negative 1, negative 2, negative 5, and I want to RREF that, or I want to, RREF that, and I get 1, 0, 0, 1, negative 1, 3. And so that tells me that my XP is negative 1, 3. So I'm going to come back here and say X is equal to C1 negative 3, 1 e to the t plus C2 1 negative 1 e to the negative t plus negative 1, 3. I'm going to look at number 3 from the textbook. It's written as x prime equals 1, 3, 3, 1 x plus negative 2t squared t plus 5. So we have 1 minus lambda, 3, 3, 1 minus lambda equals 1 minus 2 lambda squared. I'm sorry, 1 minus 2 lambda plus lambda squared minus 9 equals to 0 is lambda squared minus 2 lambda minus 8 equals to 0. Factors into lambda minus 4 and lambda plus 2 equals 0. So lambda 1 is equal to 4. Lambda 2 is equal to negative 2. And when lambda 1 is equal to 4, we have negative 3, 3, 3, negative 3, 0, 0, which turns us into 1, negative 1, 0, 0, 0, 0. K1 equals K2 equals to T. So my K1 here is 1, 1. When lambda 2 is equal to negative 2, I have 3, 3, 3, 3, 0, 0. So this is 1, 1, 0, 0, 0, 0. K1 equals negative K2. And so we have 1, negative 1. And so then I have an XC is going to be C1, 1, 1, e to the 4t plus C2, 1, negative 1, e to the negative 2t. Then I'm going to have an XP of a2t squared plus a1t plus a0, b2t squared plus b2t, sorry, b1t plus b0, and that makes xp prime equal to 2a2 t plus a1 and 2b2t plus b1. So this is going to be my right-hand side here, 2a2t plus a1, 2b2t plus b1, and then this was negative 2t squared and t plus 5 being added to, this is 2t squared plus a1t plus a0, b2t squared plus b1t plus b0. Coefficient matrix here is 1, 3, 3, 1. So I end up with a2 plus 3b2 t squared plus a1 plus 3b1 t plus a0 plus 3b0, and then I have minus 2t squared. Down here I have 3a2 plus b2 t squared plus 3a1 plus b1t plus 3a0 plus b0 plus t plus 5 equals 2a2t plus a1, 2b2t plus b1, and we'll simplify that down a little bit. All right, so the t squared term can combine over here, making this a2 plus 3b2 minus 2t squared. And then this is plus a1 plus 3b1 t plus a0 plus 3b0. And then I can bring this over to the other side, is equal to, I'm sorry, that's already combined there, is equal to 2a2 plus, this is t, plus a1. And then there's no t squared term here, so 3a squared plus 3a2 plus b2 t squared. And then we have 3a1 plus b1 plus 1t plus 3a0 plus b0 plus 5. And then this is 2b2 plus b1. So this is a much more complicated system of equations. I'm going to have to start off here solving for the a2 and b2 numbers to be able to then use them on the right-hand side to solve for the t's, to get the a1 and b1 numbers, to stick them in over here to solve for the a0 and b0 numbers. So starting off with this first system over here, where I have zeros on the right-hand side. A2 plus 3B2 minus 2 equals 0. 3A2 plus B2 equals 0. Changes into a matrix equation for me. 1, 3, 2, 3, 1, 0. And I'm going to RREF that to get 1, 0, 0, 1. And then this is solving for A2 and B2. So those are -1/4 and 3/4. Using those, I can come now and write my next system here, which is A1 plus 3B1, and then A1, 3A1 plus B1 plus 1 equals to 2A2. So A2 was -1/4 and B2 is 3/4. So that makes this turn into 1, 3, -1/2. And then this is 3/2 minus 1 is a +1/2 on this side, 3, 1. So when I RREF that, I get 1, 0, 0, 1. And these are 1/4 and -1/4. So then that lets me come to the next set here. And A0 plus 3B0, and then 3A0 plus B0 plus 5 is equal to A1 was 1/4, B1 was -1/4. So that changes to a system here for me of 1, 3, 1/4, and 3, 1. And when I subtract 5, which is 20/4 from -1/4, I get -21/4. So that turns into 1, 0, 0, 1. And this is -2. And this is 3/4. So that means that my xt, which is equal to my xc, I wrote my xc up here. Yeah, I did. C1, 1, 1, e to the 4t plus C2, and then my K2 is 1, -1, e to the -2t plus my xp, which we just found to be a, so this is -2, and then this is 1/4 t, and this is t squared -1/4, and then this is 3/4, This is -1/4, and this is 3/4, like so. So let me just check that. -1/4 t squared plus 1/4 t minus 2 in the top. And I can split those up, or I can leave it like this. 3/4 t squared minus 1/4 t plus 3/4. The book is going to have it written like this. They're just going to take this this matrix right here and put t squared there. And then they're going to take this matrix right here and put t there. And then they're going to take this matrix right here and like that. So that's a denominator 4 there. So that's how you would do number 3 in the textbook. I'm going to finish up with number 5 from the textbook. It says that x prime is equal to 4/1/3 9 6 x plus -3 10 e to the t. So my characteristic equation here, 4 minus lambda 1/3 9 6 minus lambda is equal to 24 minus 10 lambda plus lambda squared minus 3, and that equals to 0, which makes lambda squared minus 10 lambda plus 21 equal to 0. So this is lambda minus 3 and lambda minus 7 to equal 0. Lambda 1 equals 3. Lambda 2 is equal to 7. Go ahead and divide this a little bit to show the two eigenvectors that I'm solving for. So when lambda is 3, this is 1/3 9 3. That gives me 3 1 0 0 0 0. So K2 is equal to -3 K1. K1 will be T. This is -3T, which makes my K1 equal to 1 -3. When lambda 2 is equal to 7, I get 4 minus 7 is a -3, 1/3, 9, -1, 0, 0. I'm going to multiply the top row by -3. That makes 9, -1, 0, and then 0, 0, 0 here, which tells me that K2 is equal to 9K1, with K1 equal to T. This is 9T. So capital K2 is 1, 9. That gives me an XC of C1, 1, -3, e to the 3t plus C2, 1, 9, e to the 7t. Now I'm going to pick an XP of constant here times e to the t, XP A0, B0, e to the t. So when I differentiate that, I get e to the t doesn't change this, a0, b0, e to the t. So right hand side here, a0, b0, e to the t for my x prime. Then my left hand side of my equation is 4, 9, 4, 1/3, 9, 6 times x, which is a0, b0, e to the t, plus -3, 10, e to the t. So really this e to the t, which is never 0, I can kind of just ignore all that. In my solution here, kind of divide it out and make this 4a0 plus 1/3 b0 minus 3 is equal to a0. And then I have 9a0 plus 6b0 plus 10 is equal to b0. I'm going to change that into the system 3a0, bringing my a0s over here, plus 1/3 b0 is equal to 3, and 8b0, 9a0 plus 5b0 is equal to -10. Right. So that makes 3, 1/3, 3, 9, 5, -10 for my matrix equation there that I want to solve. And let's go ahead and do that. And I get matrix edit. This is 2 by 3. We have 3, 1/3, 3, 9, 5, and -10. So we're going to RREF that matrix, and change our answer to a fraction. So I get 1, 0, and then I get 55 over 36, and then 0, 1, and -19 over 4. So that's for what my A0 and B0 are for XP. So my total XT is my XC, C1, 1, -3, e to the 3t, plus C2, 1, 9, e to the 7t, plus my 55 over 36, -19 over 4, e to the t for my xp as my total solution. And that's my last one for this video. And this is the last video in my differential equation series. Some more topics, like I said, on variation of parameters in this section. In the last section, there's more topics on finding solutions where the eigenvalues are complex numbers. Um, and so go ahead and read the book and try those problems at your leisure. But this gives you a really good view of how differential equations will be useful in classes in the future. And this material is everything that I covered in both my 200 level and my 400 level differential equations courses. So hopefully you find that helpful to you going forward. Um, you can go lots of places from here with differential equations. So you may be go into linear algebra, which we've got some videos for that. Calculus 3, there should be videos for that. And maybe if you're a math major, maybe discrete math, and there might be some videos for that coming, but that's a lot harder to do examples for. So keep your eye out for any and all of those things that will be coming up in the future. And good luck with wherever you go after this course. If this is your last course, congratulations. And good luck with where you go from here. If you are coming back for another course that I have videos for, I'll see you for the next set of videos that you watch.